Hello everyone. In the last class, we discussed how to apply the source transformation method. In continuation with that, now one more problem we will solve here. Here we have one voltage source with a series resistor, and it is basically a resistive circuit. So now I have some 10-volt source, 2 ohm resistor, 3 ohm, 4 ohm, 5 ohm, okay, 5 ohms, and this is 2 ampere current source. I want to find what is the current flowing through 2 ohm resistor. This is I want to find. So as already we discussed, whenever if you observe a circuit, first you have to observe the given sources are practical sources or ideal sources. If you observe that these two are practical sources, this is one practical source because a current source with a parallel resistor, and this is one more practical source, a voltage source with a series resistor. A voltage source with a series resistor. Now, if you observe these two, as we have to find the current flowing through 2 ohm resistor, that's what we should not disturb the particular 2 ohm resistor branch. That's why even though we can able to apply the source transformation over there, don't apply over there. You should not disturb the 2 ohm resistance branch. So you just leave as it is, whatever it is, 2 ohm resistor. We'll see. We'll see. We will convert this 2 ampere and 4 ohm resistor and a current source. Will convert to a voltage source. How we can do that? Now, this is the current source I'm taking. Let us take, just to mark it as, this is point X, this is point Y. Why we have to mark, sir? Because when the current direction here, if it is upward, downward, easily we can recognize. See that it is left side, right side, it is there. That means now it is left side, it is there. So we will get confused. That's why you just mark X and Y point so that it will be easy for you to draw the final equivalent circuit. So I have one 2 ampere current source and 4 ohm resistor. As per the source transformation method, we can convert a parallel resistor, current source with a parallel resistor into a current source parallel resistor with a voltage source with a series resistor. Remember, now the current direction, if you observe, this is towards the X point. So this is my X point. Just you mark it. That's all. So now, what is the current direction? Upward. Upward direction is your positive terminal. So here, this terminal should be X and this terminal should be Y. Now, whatever the resistance is there, you just take it here 4 ohm. Now, what is the voltage? Voltage V is equal to I into R. I will get here 8 volt. Just you draw over there carefully. Where is the X? Where is the Y? Because here only we will do mistake. Now, if I draw the circuit over here, so I'm not disturbing the 2 ohm resistance branch. So 3 ohm as it is. And in between X and Y, I have to draw this resistor with 4 ohms and a voltage source. And the remaining 5 ohm is as it is. So now here it is 10 volt voltage source and this is 2 ohms current I have to find here, and here it is 3 ohm resistor and here 4 ohm resistor with a voltage source. So now what is here? Where is X? This is your X, this is your Y. So which side you have positive terminal? X side. So this is your positive terminal, this is your negative terminal. You have to remember that. And this is your 8 volts. And here is the resistance given is 5 ohm. Now, whenever if you transform definitely you will have one series parallel simplification. So we have to complete that. Any series parallel combination is there? Yes. 4 ohm and 5 ohm connected in series. 4 ohm and 5 ohm connected in series. Connected in series. Then the resultant we know that 4 plus 5 R equivalent will become 4 plus 5 is 9 ohm. We will replace that with a 9 ohm resistor. So now I am taking a voltage source with a 10 volt. It is a circuit simplification procedure. We have to draw that every step. We have to draw that. There is no direct simplification, sir. I will apply another method. No, you cannot apply because as per the question, you have to use only source conversion or source transformation method. Now 2 ohm, 3 ohm, and here it is 9 ohm, and this is positive terminal and negative terminal with 8 volts. Right now, again, if you observe here, you have a voltage source with a series resistor. Again, you have to convert this. How to convert that? Just you mark it. This is some X point. This is some Y point, because whenever you are replacing, it will be helpful for you. That's what. Here I have, this is plus minus 8 volt, and here it is 9 ohm resistance. So positive side I taken X, negative side I taken Y. This is the positive side and this is negative side. That's what I mean. Now you can convert into a current source. How can I convert to current source? Current source, positive polarity is in the upward, so the current direction is upward direction, and a parallel resistance I have to connect. What is the resistance value? The terminals I'm not changing. This is X, this is Y. So the resistance is same as 9 ohm, and the current will become, what is the current? Current will be voltage by resistance. So V by R, that is 8 by 9. If you calculate that 8 by 9, 8 by 9, if you calculate, you will get 0.88 amperes. 0.88 amperes. 0.8889 is there. You can put 0.89 or 0.88 amperes. It's fine. Now you connect the same terminals over here, positive, negative, resistor. Here is the X and Y terminals are marked between these two 3 ohm resistor. So in between that X and Y, one 9 volt 9 ohm resistance is connected. This is your 9 ohm resistance, and the current source is connected. Now see the current direction, whether it is, this is the X point, right? This is your X point. This is your Y point. Don't change that. Here anyway 2 ohm resistor, direction of current I have to find, and this is 10 volt. Now, so the current direction is towards X. That means here also upward direction. What is the current? 0.88 amperes. Now again, if you observe 3 ohm and 9 ohm connected in parallel. So you have to write, so 3 ohm and 9 ohm connected parallel. Connected parallel. So just if you draw one dotted line, that will be good. If you are drawing a dotted line across here, that will be good. So how can I write that? R equivalent is equals to 3 ohm parallel to 9 ohm is equals to 3 into 9 by 3 plus 9. How much you will get? 27 by 12. So 27 divided by 12, you will get 2.25 ohms. 2.25 ohms. Now again, you have to draw the same circuit. Here 3 ohm and 9 ohm replacing with a single resistor, that is 2.25 ohm, and a current source here 0.88 amperes. So this will become 2.25 ohms. And you should not disturb this 2 ohm resistor branch, and this is 10 volt. Now if you observe again, if I want to find the current flowing through here, this circuit is again, I have to simplify. So 0.88 ampere with 2.25 parallel combination, again I have to simplify. So what I have to do here, I'm going to draw one dotted line. So this next step, I have to simplify this. So I have to just again you mark it x and y for your reference. Just you mark this is x, this is y, to avoid confusion. That's all. So now here I will draw the current is 0.88 ampere and with a parallel resistance of 2.25 ohms. Now, if I convert to a voltage source, if you observe, the current direction is upward. That means here is your positive terminal, here is your negative terminal, and the series resistance you will get. So same, this is x and y you marked over there. Same mark, same here also you mark x and y. And what is the resistance? Same 2.25 only. And what is the voltage? Voltage is current into resistance. 2.25 into 0.88, you will get around 1.98 volts. 1.98 volts. Okay. So now you have to remember x and y, how to draw that. So again, I will go back to the circuit. So 10 volt, 2 ohms, it is connected. I will draw that circuit. Here, plus minus. This is 2 ohms. This is 10 volt. And here is the x point we considered over there. Here is x and here is y. So now at x point, I have to draw the resistance of 2.25, and here I will get the voltage is 1.98. So further you can simplify one more step, or directly you can write the KVL over here. Better, I will suggest you to draw one more step. What is that? Here if you observe the direction of these two 10 volt and 1.98 volt are connected in series. Whenever two voltage sources are connected in series, we have to add. Now, add or subtract depends on the polarity. Now, if you just walk in one direction, either you are walking in this direction or reverse, you are walking in one on another direction. First, which polarity you are crossing? First, you are start walking here. You are here. You just walk from here. You will first cross the positive terminal, and then if you observe here, you are crossing negative terminal. That means both are opposite terminals. If both are opposite, you have to subtract one from another. So higher polarity will get that. So here I will get plus minus, and the remaining circuit no change, 2 ohm, and the current is I. Here it is 2.25 ohm, 2.25 ohm, and here the voltage will become 10 minus 1.98. You will get 10 minus 1.98, you will get 8.02 volt. You will get here 8.02 volt. Now, if I want to know what is the current I is nothing but total voltage divided by 8.02 divided by total resistance, that is 2 plus 2.25. You will get 8.02 divided by 4.25. 8.202 divided by 4.25. You will get current I is equals to 1.887 amperes. 1.887 amperes. So you can write one more step here. I 2 ohm resistance is 1.887 amperes. You can put box for this. So this is how we can apply the source transformation method. Now, in this one more one more form is there. Just we'll see that form also. We can say that that is source shifting method. Source shifting method. Source shifting method. In this source shifting method, we will get ideal sources. First, we will convert to practical sources. Then the procedure is same. How we will apply the source conversion, source transformation. Procedure is same. First, I will take one simple circuit in the source shifting method. Here is the one resistance. So this is the classical problem. General we will explain in the basic classroom. So that's what here. Voltage source and current source here. Now this is the 3 ohm resistance, 1 ohm, 2 ohm and 4 ohms. Let us take this is 5 volt and this is 2 ampere current source. Now if you observe this circuit, you have the current source, you have the voltage source, but these two are ideal sources. Sir, how you are telling ideal sources? Because I have a voltage source. If there is a resistance connected series to that voltage source, then I can say it is a practical source. Otherwise, it is looks like this. There is no resistance, means only voltage source will be there. That we can say that ideal source. In this branch, there is no resistance connected series to the 5 volt. There is no resistance connected parallel to the 2 ampere. So now I can say that this I have to first convert to practical sources. Then the methodology is same. How we done the previous problems, methodology is same. Sir, then how to convert that? Just simple, very simple procedure. Where is the current source? Yes, here is the current source and the direction is like this. Now you just trace that where is starting. Here it is the starting point. Let us take point A and where it is terminating. At this point it is terminating. Let us take point B. Now the current source is traveling from A to B. What I have to do? I have to remove this path, but I have to travel A to B only. I have to travel from A to B. I have to reach. My starting point is A. My ending point is B. So what I will do here? I will find one more junction. Right. So if you observe here, here is one junction is there. Here one junction is there. So which junction you will prefer? I want to start from A to B. I found two junctions. One is C junction, another one is D junction. Which junction you are going to prefer to reach B point? Obviously, sir, I will go for A to C and C to B is the shortest path. Is it clear, right? So now what I will do here, same circuit I will draw here. Same circuit. Current source, I am not going to draw that. This is your 3 ohms, 1 ohm, 2 ohm, 4 ohm resistors. Now, current source you have to remove first. And where it is starting? From A it is starting. No, you just take that. A is your point. So directly I am not going to B. First I will go to, here is the C point we marked, no? So this is A point, C point and B point. So now I am not directly going to A to B. What I am doing? First I will travel A to C. Then C to B I am going to travel. So A to C when you are traveling, this is your current source of 2 ampere. C to B I am traveling. This is your current source of 2 ampere. Now if you observe 2 ampere parallel 1 ohm resistor is there. Here 2 ampere parallel 4 ohm resistor is there. So this is practical source. This is also practical source. Okay. Now, for example, they will give that any one branch you have to find the current. So in this question, they given find the current flowing through 4 ohm resistance. Now, whenever if you got the problem like this, you should not disturb this 4 ohm resistor. You don't disturb this 4 ohm resistor. You have to keep as it is. So remaining branches you can simplify. That is 2 ampere connected 1 ohm you can simplify, and 3 ohms you can simplify. Those and all you can do. Now here we have 5 volt voltage source is there. What we have to do that? So how to simplify the voltage source also I will tell you now. So same circuit, because once we have done the current source voltage source, we will do the current source transformation we have done. No, that's a similar way we have to do the voltage source transformation also. So here it is the 3 ohm resistor, 1 ohm, 2 ohm. So now this is the 4 ohm resistance, and we connected one parallel current source. Here one parallel current source we connected. This is also 2 ampere, and here also 2 ampere, and this is 1 ohm, 2 ohm. Here it is 4 ohm. I have to find the current here. I should not disturb. Now, if you observe, previously, whenever current source, whenever you were taking the current source, you just removed that direct branch A to B. A to B, you directly remove that branch and you traveled A to C, C to B, you traveled. Similarly, if your voltage source is there, first you have to identify what is the nearest junction. What is the nearest junction? You can say that this is my nearest junction. Now, whenever you have a nearest junction, you just take this voltage to source to the junction. Just walk here along with the voltage source. Now, whenever if you are going here, first which terminal it will go first? Positive terminal, next negative terminal. And this junction has two routes. In both the routes, you have to take that. First will go to the positive terminal, next it will go to the negative terminal. So that is what we have to draw when we are transforming the voltage source. Now, I'm going to draw here. I found first voltage source is there, that branch I will short circuit because I taken that voltage source. No. So, one second. I taken that voltage source to the junction. The junction I have taken. Now there is no voltage source here. You have to make it short circuit. You have to make it short circuit. At junction, it is split into here one voltage source and here one voltage source. Two voltage sources it came. So how the polarity you have to make? Just observe, positive terminal will go first. Here is the positive, negative is there. No, that positive terminal will go first. Here it is positive. Another one is negative. This is positive. Another one negative. So I will draw outside so that it will be more visibility will be there. So this is your positive terminal. This is your negative terminal. Plus minus. Is it clear, right? What is the voltage? Same voltage, 5 volt. Here also 5 volt. 5 volt. Now, you observe here, 5 volt connected series to the 3 ohm resistor. It is a practical source. 5 volt connected series to the 2 ohm resistor. It is also practical source. Now, in these two steps, what we have done, the voltage source and current sources, previously in the question, they given ideal sources. Now, we converted to practical sources, then the procedure is same. What is the procedure for source transformation? Is 2 ampere 1 ohm connected in parallel. Simplify that. 2 ampere and 1 ohm, 2 ampere and 1 ohm connected in parallel. What is the equivalent voltage source? This is the voltage terminal, and this is your, let us take, this is your x point, this is y point. Where is x? This is your x point, this is y point. Just to draw the circuit, it will be helpful. Now this is your x point, this is your y point. So the resistance is same of 1 ohm, and what is the voltage? Voltage is I into r, that is 2 volt. You just substitute there, I mean you have to draw there. So how you are going to draw that? So the 3 ohm and plus minus 5 volt is there. Here I found x point, x is connected, one resistance is there. From here one resistance is there, and positive terminal connected to the x and negative terminal to y. What is the voltage we got? 2 volt, and the resistance is 1 ohm. So a y point I reached. From there I'm drawing 2 ohm, and here also voltage source is there, you as it is you draw. And here is the 4 ohm resistance, parallel current source is there. We'll talk about that. Parallel current source of 2 ampere. I should not disturb this 4 ohm resistance, and 2 ohms with a voltage source of 5 volt, and this is 3 ohms. Now just now we have done the transformation or conversion we have done. What is the conversion? Current source to voltage source conversion we have done. So now we have to simplify that. If you observe from here to from here, you just see that here to here 1 ohm and 3 ohm series, 2 volt and 5 volt also series, but we have to check whether what polarity they are having, right? So first 1 ohm and 3 ohm series, right? So 1 ohm and 3 ohm series, then write it here 1 ohm, and you have to practice along with me so that it will be easy to understand. 1 ohm and 3 ohm are in series, so it will become, our equivalent will become 1 plus 3, 4 ohms. And I don't know whether these 2 volt and 5 volt resistors connected same polarity or opposite polarity, but I know that they connected in same series because same wire. Now if you see that, I'm just walking in one direction. When I'm walking in this direction, first I got negative terminal, I saw the negative terminal. Then if I go here, first I saw the positive terminal. Only one direction you have to walk. When you are walking from one source to the another source, you just observed that here you found the negative terminal and there you found the positive terminal. That means both are opposite. If both are opposite, obviously the subtraction we have to do that, right? So 5 volt and 2 volt are in series and opposite. So we, how much you will get? 3 volt, same as 5 volt source. How the polarity will be there, no, same polarity you will get. So now I have to draw the circuit like, now the it will 3 and 1 is connected in series, it will become 4 ohm, and here is the voltage source. It is same as the 5 volt polarity, but the voltage will become 3 volt. These are done. Now we have this 2 ohms, and here it is plus minus 5 volt. So here is the current source of 2 amperes. This is the 4 ohm resistance. Right. So now you have to simplify this circuit. How you are simplifying? 2 ohm, 4 ohm parallel. This entire point, this next another point, 2 ohm, 5 ohm, 5 volt connected series, 4 ohm, 3 volt connected series, but all the branches are connected in parallel. So if I draw the circuit, it looks like this. 2 ampere, 4 ohms here. Now, what is the first one? 2 ohm, 2 ohms and 5 volt. This is 2 ohms and this is 5 volt. And this is how much? 4 volt, 4 ohm and 3 volt. 4 ohm and 3 volt. Now, what is the polarity? Check that this upward direction current is connected to this junction. Let us take some X and this is Y. So, positive terminal connected to X. This also positive terminal connected to X. So, positive side connected. This is the some X point. This is some Y point. That is only for your understanding purpose. So this will be positive terminal and this will be negative terminal. Now we have to simplify this again. How I can simplify this? Now I have 2 ohm resistance and 5 voltage source is there. 5 volts, 2 ohm. How I can convert this one to a current source with a parallel resistance. So parallel resistance is same as 2 ohm and the voltage will become V by current. If I want to calculate V by R, so it will become 5 by 2. So 5 by 2 will become 2.5 ampere. One I can do. So anyway, this is X and Y, this will be X and Y. One more branch also there. What is that? 4 ohm and 3 volt. Same thing. 4 ohm, 4 ohm and 3 volt also connected, right? So that also we will simplify. 4 ohm and 3 volt. 4 ohm and 3 volt. Now again I will simplify here. The direction of the current always representing here positive terminal wherever it is there, it direction like this, right? So generally for sources the current will flow from negative to positive terminal. That's what. So now here it will become 4 ohms and the voltage 3 volt and 4 ohm is there, then the current will become 3 by 4. It will become 0.75 ampere. So between X and Y. So if I draw these two conversions in one circuit, if I draw that, I'll get like this. I have 2 ampere and 4 ohm, 2 ohms. This is 5 by 2 or we can say 2.5 ampere. And the resistance is 4 ohm and the current is 0.75. Current direction is upward 0.75. You should not disturb this 4 ohm branch. Remaining you can disturb. Remaining you can alter. That is the disturb in the sense you can alter that. Now already we discussed when the current sources are connected in parallel. If I have a current source here, if I have current source here, just observe both are same direction or opposite direction. 5 ampere and 2 ampere. Just for example. So if both are opposite, you will get the subtraction current, which one is higher? 5 ampere is higher. The direction of current is 3 ampere with upward direction. 3 ampere with upward direction. Similarly, here if you observe 2 ampere upward, 2.5 upward, 0.75 also upward is there. So then your circuit will become then your circuit become current source which is equivalent to 2 plus 2.5 plus 0.75 because all are connected in series. So 2 plus 2.5 how much? 4.5, 4.5 and 0.75. So we'll get 4.5 plus 0.75, 5.25 amperes. 5.25 amperes you will get. So now here my current will become 5.25 amperes and 4 ohm resistance is same. I'm not going to modifying because I have to find the current over there, and this remaining terminals 2 ohm and 4 ohm is there. You can say that 2 ohm and 4 ohm connected in parallel. Before that step on we have to calculate that. So now I will write it here. 2 ohm parallel to 4 ohm, it will become 2 into 4 by 2 plus 4. So 8 by 6. So 8 by 6 how much? 1.33 ohm. 1.33 ohm. So now I will get one more resistance with 1.33 ohm. So now I simplified all the branches because 2 ampere, 2.5 and 0.75 I covered. And 4 ohms I drawn here, and 2 ohm and 4 ohm, these two, this 2 ohm and this 4 ohm connected in parallel, we got it 1.33 ohms. Now if I want to know what is the current flowing through 4 ohm resistor, if I want to know what is the current flowing through 4 ohm resistor, I 4 ohm, now you can apply current division rule. What is the current division rule? Total current into where you want to find the current 4 ohm. What is the opposite resistance? 1.33 divided by total resistance 4 plus 1.33. You will get 5.25 into 1.33 divided by 5.33. So 1.33 divided by 5.33 into 5.25. You will get I4 ohms is equals to 1.31 amperes. 1.31 amperes. This is what you are going to get. I4 ohm is 1.31 ampere. So this is the method we can apply when we have a ideal sources, and source shifting method is important. In the next class we will see nodal analysis. Thank you.